Welcome back to another video presented by the AutoPilots. Today's lesson is on the dual hydraulics failure. This lesson is split into two parts, a theory part and a practical part. To head straight to the practical, head to this time in the video. Note that there are some sim glitches in the practical, but we'll try to point these out. We hope you find this helpful. So let's begin with the theory. Welcome to this presentation on the Airbus A320 hydraulic system. In this lesson we will briefly review the layout of the hydraulic system of the A320, and then dive into a dual hydraulic failure in our Microsoft Flight Simulator. The A320 hydraulic architecture is comprised of three systems: green, yellow, and blue. Let's have a deeper look into each system. The green system is driven by Engine 1. It plays a big role in driving some important systems, such as the landing gear and flight control surfaces. The system consists of a reservoir, a fire shut-off valve, the pump driven by Engine 1, an accumulator, which allows it to maintain constant pressure of 3000 psi. The yellow system consists of a reservoir, a fire shut-off valve, the pump driven by Engine 2, an accumulator, the electric pump, and the hand pump. Here are some of the system that the yellow hydraulics powers. The blue system is driven by an electric pump, which is powered in three ways: automatically, when in flight; manually, when the crew presses the override push button; or by the ram air turbine, RAT. The RAT has a hydraulic pump coupled to it, and will deploy if there is an AC bus 1 and 2 fault, or if the crew manually extend it using the push button. The blue system drives or part drives important systems such as slats, rudder, ailerons, elevators, and spoilers. The power transfer unit, PTU, enables the yellow system to pressurize the green system, and vice versa. It comes into action when the differential pressure between the two systems is greater than 500 psi. We also need to be mindful of PTU usage in certain hydraulic failures. The PTU should only be used if there is a pressure-related failure. If the hydraulic reservoir is low, the PTU should be switched off to prevent overheat. Typically, we will only use this on the ground to pressure the yellow hydraulic system, like in single-engine taxi operations. In case of a failure of the yellow system in flight, we will only use the electric pump if we have an Engine 2 pump low-pressure fault. For other yellow hydraulic failures, we will not use the electric pump as this will be ineffective and could cause it to overheat. This diagram is useful, as it shows in detail the systems that each hydraulic system supplies. Take your time to be familiar with this. It is important to have a good understanding of what systems will be affected if there is a hydraulic failure. This increases capacity and improves failure management. The hydraulic system can be displayed on the SD page. Here we can clearly see all the key components of the system. Different hydraulic system failures will affect the nature of the flight differently. This is due to influence they have over other systems such as flight controls, landing gear, and overall performance of the aircraft. The following slides cover what you should consider in this scenario. The first thing we should consider is the controllability of the aircraft. We know that the hydraulic systems are linked with the flight controls. In some cases, in particular dual failures, we might lose a lot of the elevator, meaning that, whilst it still is operational, it might feel sloppy. Similar logic applies to the flaps and slats. It may be that we lose the slats entirely, green and blue failure, or flaps entirely, green and yellow failure. This is going to affect our approach speeds and attitudes of the aircraft. Not only do we need to think about the aircraft in the air, but also once we've landed. Hydraulic failures can cause us to lose one, or even both reverses. Our braking ability might also be affected. So it would make sense for us to look for a long runway, or certainly one that isn't performance limiting. Nose wheel steering is also an important thing to consider. A failure of the yellow hydraulics will result in no nose wheel steering. How will this affect your operations? Hydraulic failures, especially dual hydraulic failures, will always result in an increased workload. The workload may be increased by loss of autopilot, flight control law degradation, the plane could be in alternate law, or even direct law with the landing gear down, landing in abnormal configuration, extensive ECAM procedures, more considerations for approach and landing, extra performance calculations. For dual hydraulic failures, there are summaries which cover cruise, approach, landing and go around. These summaries are good to review at certain stages of the flight. They can be mentioned in the expanded checklists part when dealing with the ECAM. The status page can also help show you what you have and don't have. A dual hydraulic failure, with a lander SAP in red, should result in a mayday being made to ATC. Just think, what happens if the third hydraulic system goes? Then we really are in trouble. However, this shouldn't mean you rush. Make sure the ECAM is completed first. Since this will be a hand-flown approach with a lot to consider, it is worth briefing. The selected speeds used on FCU, for flap, slat issues, the landing gear gravity extension procedure, the approach configuration and VAP, the how are you flying a stabilized or decelerated approach, tail strike awareness if landing in an abnormal configuration, braking and vacating the runway, especially if you have no nose wheel steering, and the go-around actions. In the event that the aircraft is now in alternate law, due to the dual hydraulic fault, extra considerations will have to be taken into account when on the approach. In most cases, set the flaps on a level segment, then when the aircraft is trimmed out and at VAP speed, select gear down. We will fly it like this: flap 1, flap 2, flap 3, and flap full when reaching the glide slope. We are still in alternate law here. Then when on the glide, gear down. You enter direct law and use man pitch trim in amber. All of this will reduce workload and any unnecessary trimming. The failure management can be broken down into 3 steps. Step 1, Aviate, Autopilot, Auto Thrust. What law are you in? Do you have flight directors or do you need the bird? Stabilize the flight path. Navigate. What terrain is there around you? What weather is there around you? Is there other traffic that you need to consider? And communicate. Consider making the PA, attention, crew at stations. Or you could maybe inform ATC once management of failure complete. Step 2 involves diving into the failure. Start with the ECAM. Go through the ECAM carefully, highlighting the failure and associated failures. Have a thorough review of the status page. Are there any resets you can do? In this case, there are none. Are there any expanded checklists? In this case, yes, the summaries in the QRH, we can review this afterwards. Now that the ECAM is complete, move on to step 3. First have a review of the summaries page in the QRH. Now perform a DO-DAR or a 4-deck. This is a failure management and option generation model, which varies from airline to airline. In this scenario, we'll use DO-DAR. D. Diagnose the issue of the dual hydraulic failure. O. Options. Continue, divert or return. We want to get on the ground soon. What airports do we have around us? D. Decide. Let's pick an airport which has a long runway, good weather, preferably strong ATC and maintenance at base. A. Assign. Assign roles of setting up the MCDU, talking to ATC, crew, passengers and company, PF and PM, and a brief. And R. Review. How is the plan? Does it prioritize safety? This is a strong and robust model to manage what is a fairly challenging failure. To recap, it is important to have a good knowledge of the Airbus hydraulic system. One loss of a hydraulic system can cause additional workload. A loss of 2 hydraulic systems is a lander SAP and will cause a large increase in workload, including most likely a loss of autopilot, and the aircraft will be in alternate law. You have the summaries page in the QRH for guidance. Sometimes the failure can be performance limiting. Failure management is key in this. Keep calm and work things out methodically. Theory complete, and it's time to jump into a practical demonstration with our 2 pilots.
Last caution.
Yeah, so aircraft's flying fine. No weather ahead, autopilot's in. And using the ATC nose, so read ECAM.
So we seem to have something wrong with the hydraulic brew reservoir, low air pressure, which is confirmed on the systems page of the blue hydraulic and on the overhead as well with the fault light.
Yeah, that's also confirmed. So my radio's ECAM actions.
So ECAM actions, hydraulic brew reservoir, low air pressure. If pressure fluctuates, blue ELEC pump off.
Yeah, pressure's fluctuating.
It is definitely. So blue ELEC pump off. So blue ELEC pump confirmed.
It's confirmed.
Is off. Last caution, hydraulic blue system low pressure. So we have fuel consumption increased and FMS prediction unreliable.
Roger.
Clear hydraulic.
Clear hydraulic.
So secondary failures, we have flight control. So, well, there's still some are moving, I think due to turbulence, but it's showing we lost spoiler 3 and all the associated blue hydraulic systems.
Yeah, that's all checked.
So clear flight control.
Clear flight control.
Status.
Stop ECAM. So there's no resets that we can do. Expanded checklist wise, there might be something in the FCOM to look over, which we can do once we get to the cruise. But for now, read status, please.
So status: fuel consumption increased. Approach procedure: hydraulic low pressure, blue ELEC pump auto. Landing distance procedure apply. FMS prediction unreliable as we mentioned. Slats will be slow. Cat 3 single only. In operative systems we have blue hydraulic, spoiler 3, Cat 3 dual, and blue ELEC pump.
Okay.
Status.
That's all understood. Remove status.
ECAM actions completed.
Great. Okay, so we're still in the climb at the moment. We've got about 3,500 feet to go. Looking at that status, I mean, it shows basically what we can expect with blue hydraulic failure. Cat 3 dual in operative, that's fine because in Barcelona it's looking like Cat 1 weather. So I'm happy with that. So yeah, what are your thoughts regarding this then?
Yeah, it's definitely not a major issue. Let me bring the hydraulic page up. Yeah, we definitely obviously still have green and yellow working fine. Yeah, besides really losing one spoiler, there's not many implications with that. So.
So yeah, I agree. So are you happy to continue to Barcelona for now?
Yeah, definitely.
And then we'll just continue that. I'll let engineering know as well and see what they can do for us when we get to Barcelona.
Yeah. Sounds good.
Cool.
So my radios then.
Your radios.
Mass caution.
Roger.
Master warning.
Okay, let's see autopilot off.
Yeah.
So I have control.
You have control.
Autopilot's off. We still got the auto thrust at the moment. We will need to descend out of RVSM airspace shortly, but let's just focus on the failure right now.
Yeah.
There's no weather ahead, and
is it worth trying the autopilots again? AP2 as well and AP1?
Let's try that. So AP1 or AP2. We've got nothing there.
Okay.
Okay, so yeah, okay, confirm the failure, please.
Okay, we seem to have lost the yellow hydraulic system, which is confirmed on the flight control systems page, and with the fault lights on the overhead panel as well for the yellow pump.
Okay, that's I agree with that. So my radios then, ECAM actions.
So we have auto flight AP off, clear auto flights.
Clear.
Hydraulic blue plus yellow system low pressure. Yellow ELEC pump on.
So we don't want to turn that on actually,
Yeah.
because that will overheat it, won't it?
In that case, yellow engine 2 pump off. So yellow engine 2 pump off. Max speeds 320 knots or Mach decimal 77. So that's, we are doing Mach decimal 77. Right
Okay.
now.
So can you just select just slightly lower speed, maybe just decimal 75, please?
Yep.
Thank you.
Maneuver with care. For go arounds, max pitch 15 degrees. Fuel consumption increased and FMS prediction unreliable. Clear hydraulic.
Clear.
And we have a PTU fault as well, which is confirmed on the overhead.
Yeah, that's understood. Obviously, we have a hydraulic leak as well, so
Yeah.
PT wouldn't be much use anyway. So yeah,
So clear hydraulic.
clear hydraulic.
So secondary failures, we have land ASAP red, and flight controls. So we've lost all the associated yellow servos as well, and 4 and 2 spoilers as well.
As well as 3, yeah. Okay, sure.
And obviously, as you said, we've lost all the hydraulic on yellow. So
Cool. Understood.
clear flight control.
Clear flight control.
Status.
Stop ECAM. So let me just swing this round level. So there are no resets that we can do. Expanded checklist. There is something in the QRH.
Yeah.
We got the summaries for the hydraulic failures. So we can have a look at that shortly. But there's nothing else I can think of. There may be something in the FCOM just for additional information. Apart from that, read status, please.
So status. Max speed 320 knots, Mach decimal 77, as we mentioned. Maneuver with care. For go around, max pitch 15 degrees and fuel consumption increased. Approach procedure. Dual hydraulic low pressure. Blue ELEC pump auto. If hydraulic not recovered, landing gear gravity extension and landing distance procedure apply. FMS prediction unreliable, and slats flaps will be slow.
Cool.
Inoperative systems, we have blue plus yellow hydraulic, right elevator spoiler 2, 3, and 4. Speed brakes. We've lost both autopilots. We're Cat 1. We won't have nose wheel steering nor reverse 2. And cargo door, PTU, obviously yellow engine 2 pump, and the blue electric pump, as well as the yaw damper 2.
Okay, so from that list then, just put it on my ID.
Sorry,
So from that list, a couple of things to consider.
yeah,
Firstly, another expanded checklist in the gravity extension, QRH.
yeah.
The slats and flaps are going to be slow.
Well, actually, sorry, you mentioned the gravity extension. I think is included in the summary. So
Is included? Yeah. Okay. Perfect. That's good. Good to know. So the slats, flaps are going to be slow for the approach. We are going to be doing this with manual approach. Landing distance will be affected, and once we land, we're not going to be able to
yes,
vacate
we'll
the
need
runway.
a tow truck.
Okay. That's it. Yeah. So we got to let ATC know that as well.
Yeah.
Cool. Okay.
That
So
makes sense.
remove status then if you're ready.
Yeah. Remove status. Decam actions completed.
Okay, great. I'm just going to make a PA attention cruise stations.
Yeah.
Attention cruise stations. Okay, so obviously it's land ASAP in amber. So
red.
let's just sorry in red. Thank you. So let's begin a quick DODAR. So
Yeah.
we diagnosed the failure of a dual hydraulic failure, and it is the blue and yellow hydraulic system,
Yeah.
which we have. So we're just on green. Options: continue, divert, or turn. We've got option wise. We've got Venice to our left. We've got Ljubljana behind us, and in front of us we've got Milan, about 20 miles away from us.
Yeah.
What do you think is a good option?
Well, from all the weathers we've had, I mean, the weather seems quite. I mean, it's Cat 1 everywhere, so that's really no issues there. Obviously, you talked about landing distance, so we definitely know Venice. Does it have 2 runways? Venice?
It does, yeah, and one's 3,300 meters long, which is yeah, plenty.
So
of length.
the closest one with the long runway definitely seems to be Venice, even though obviously Milan is a bit further away. So obviously it's land ASAP red. So I would maybe tend towards Venice, as we've both been there as well.
Yeah,
So
I agree. I agree. That sounds that all sounds good to me. So decide, are we happy to go to Venice then?
yeah,
Quite near. So I'm gonna assign some roles now. So I'll just keep the radios for now. I'll let ATC know what's going on.
yeah,
Once we get clearance to divert to Venice, I will then ask you to set up the box for the approach.
yeah,
Then I will probably give you control, and I'll do a NITS brief to the crew and passengers,
yeah,
and also inform our company. And then I'll brief for the approach, and then we can begin flying the approach into Venice.
yeah.
Is there anything
That
else
sounds
you'd
good.
like to add at this point?
No, obviously, yeah, we'll have to, I don't know if you said it, we will have to check our landing distance. But,
Distance, yeah, absolutely, yeah. I'll ask you to do a
Yeah, I
landing
can do
before. Brilliant. So Airbus 123, Mayday, Airbus 123. We have a dual hydraulic failure. We are requesting to divert to Venice. Request initial vectors. for an ILS approach into Venice. Cool. Could you set me a heading, please, of 130?
Yeah.
And begin our descent to flight level 100, please.
There you go.
Brilliant. We're just going to disregard managed speed for now, but we'll definitely have to manage it at some point. Just watch that we don't exceed that speed limit as well. And yeah, if you don't mind just doing a landing performance, obviously we know that the runway is going to be long enough. It's 3,300 meters. That's plenty of distance, but if you just want to do a quick landing performance, and then I'll ask you to set up the box if that's all good.
Yeah, will do.
Excellent.
So wind-wise, well,
And just to quickly look at the QRH hydraulic blue and yellow system low pressure summary.
yeah.
If you're ready. It's in the cruise. It's pretty. There's not much to it. Just maneuver with care. Flight controls remain in normal law, which we can see. Increased fuel consumption, and for landing, you do a landing performance assessment.
Yeah.
Brilliant. All good.
Yeah, so landing distance for ILS 04 right, 3,300 meters, is showing. It's still computing. Yeah, it's the factored landing distance is well within the 3,300 meters, so we have about 1,000 meter margin.
Beautiful. Okay, excellent stuff. So, yeah, that's pretty much as expected. So, yeah, if you don't mind, would you mind setting up the box then for an ILS approach, runway 04?
Will do, will do. ILS Zulu 04 right.
Yeah, the wind favours the 04
Yeah.
approach as well. So we'll get there. You just mark up about 280 knots, please.
Yeah.
Thank you.
So Cat 1 minima is 210. If you want, I can put the V up right now.
Yes, please. Yeah, put it all in there.
So flaps full 132. It's actually the one we have in. So
Smashing. All good. Is there any questions, suggestions that you have for a quick review?
no, we can probably do the approach checklist at some point, but otherwise,
Yeah, great. Okay, so let's start on this on heading 130. So can you just plug that up, please? So we got heading, and we can continue our descent to 5,000 feet for now. And what's the QNH?
QNH is 1010.
Set 1010, please. Cool. So, okay. So approach checklist, please.
So, approach checklist. Barrow ref,
QNH 1010.
600 to go.
Checked.
QNH 1010, seatbelts,
On
minimum.
210 set.
Barrow 210, auto brake,
Medium.
and EFB.
Yes, those connected.
Those connected. Approach checklist completed.
Brilliant. Speed out star.
Checked. I'll clear the hydraulic page.
Excellent, yeah. Could you just extend the sense line for me, please, from Fox 04 right?
Yep. Radial in, so that should be
Yeah, it should come up automatically.
219. Yeah, that's about it.
All good. And we can descend 3,000 feet, please.
Now blue.
Yeah. All that. And
Yeah.
descend 3,000 feet.
There you go.
And could you confirm that the approach phase is activated?
It is.
Great. Manage speed, please.
Speed managed.
Thank you. Landing lights on.
Lights on.
I'm going to shortly we'll be going direct to Fox 04 right, so let's get ready for that.
Yep.
Okay, we can start configuring, even though we're in the descent, that's absolutely fine.
Yeah.
So flaps 1, please.
Speed check. Flaps. 1. So status, no changes. Remove status.
Yes, please.
Do you want me to set direct?
Yes, please. Nav and arm the approach push button, please. GS lock blue, cat 1. GS lock star.
Checked. Miss
Flaps
approach.
2.
Sorry, speed check. Flaps 2.
Yeah, and that's 5,000 for the missed approach, thank you. Visual.
Checked.
Flaps 3, please.
Speed check. Flaps 3.
And if you want to switch on the blue pump, see if we get anything out of that.
Right. Blue pump. Confirm.
Confirmed.
Last caution.
No,
Doesn't seem to be.
No. Okay, then switch it off then.
Alright, no. Blue pump confirm.
Yeah, it's not good. Yeah, confirmed. Yeah, the pressure's still fluctuating. That's fine.
I'll disregard.
2,500.
Yeah.
Radio altimeter live.
Yeah. Alrighty then, if you just want to get the gear down as per the checklist.
So gravity gear extension, hand crank, and pull. Let's see. So it's let's assume that works with landing gear lever down and gear down indications check.
Excellent.
Green.
Brilliant. Spoilers to be arms, mate.
Yeah. Spoilers armed and lights are on.
Excellent. Thank you. Flaps full.
Speed check, flaps full.
Okay, yeah, we can disregard that.
Disregard.
Landing checklist, please.
Cabin.
Secured landing.
Go around out.
5,000 feet set.
ECAM memo. So I'll just do it manually. Landing gear is down. Signs are on. Spoilers armed. And flaps are set. Landing
Great.
checklist completed.
Thank you. There's our clearance to land.
Yes.
$1,000.
Thanks.
$500.
Stable.
Checked.
$100 above.
Correcting that.
Check.
Minimum.
Continue.
Check.
100. 50. 40. 30. 20. Retard. 5. Retard. Retard.
Spoilers. Reverse green. Or one reverse green and decel. 70 knots.
Checked. Coming to stop on the runway.
Checked.